YakChat, a podcast from BlakYaks. In this episode, Stuart Anderson, Chief Engineer, and BlakYaks CEO Dirk Anderson discuss the evolving landscape of container technology.
Hi, I'm Dirk Anderson. Thanks for joining. Welcome. I head up the BlakYaks business. Today I'm joined by Stuart. Welcome. Thanks for joining us, Stuart.
Thanks, Dirk.
Today we're here to talk about enterprise containers on Azure specifically. In the last episode, this is a second episode in a series of 5. In the last episode, we talked about infrastructure as a service, virtual machines, and made some references to the operational burden and overhead associated with running those platforms at scale. Enterprise containers is part of the answer to that industry problem. But before we get into that, Stuart, do you just want to introduce yourself and your professional background?
Stuart Anderson, Chief Engineer at BlakYaks. So been building enterprise kind of platforms for quite a long time, doing lots of the engineering work and the kind of architectural work. Mostly in Azure in recent years with the companies we've had, but prior to that, lots of kind of bare metal work as well, going back longer than I'd care to remember. Been in charge of development teams, data science teams, but real focus on DevSecOps in recent years, lots of grid compute platforms, ECP type platforms, and the stuff we're going to get into today.
Okay, cheers, Stuart. Thanks for joining us and taking the time. But before we get into the broader subject of enterprise containers or enterprise containers on Azure, do you want to just set the background and the scene for the listeners? You know, why containers? What is all that about? Just if you could expand on that a bit.
Yeah, I think it's the right thing to do. I think pretty well trodden ground, the whole containers and Kubernetes and that kind of landscape. But I don't think you can have a conversation like this without walking that path a bit and starting with why containers and why Kubernetes and then walking through to the kind of enterprise container platform chat that we want to have. So the start point is, why containers? What do they give you? What are they for? How do they help? So a container really is a software package that contains your code, its libraries, its dependencies, maybe some system tools, everything it needs to run as a complete independent unit. That's different to how you might deploy in a VM, because virtual machine, you're deploying your software onto it. It has your dependencies, hopefully. If it doesn't have your dependencies, that's when things don't work. You're dependent on the configuration of the virtual machine for your software to run properly. And the old thing that people laugh at of the developer saying, what's okay in my machine? That's the cause of stuff like that, right? So with containers have these isolated unit of deployment. The consistency guarantees that they give you take away that kind of issue. So if it runs on a developer's laptop, it's going to run on bare metal, it's going to run in the cloud, it's going to run in Kubernetes, anywhere you need it to, you've got a really high guarantee that it's going to be as consistent enough that it will do exactly what you want it to. That brings some other benefits. So because the container image is really small, typically the Scratch container, you can have 10 megabytes and it runs your service, the little Go library or something. The really lightweight Linux image, it could be 40, 50 meg and it runs your software just fine. And you don't need the whole cost of a whole operating system, the running the operating system, the storage costs that are associated with that, the processing costs, the memory, all that stuff. So they're really lightweight, which means you can turn them on really quickly. You can have multiple of them running at really low cost. There's a whole lot of efficiency benefits from running that way. There's some isolation guarantees that come with that as well. So with VMs, you often get noisy neighbor problems where one process takes all the resources, all the memory, all the CPU, and starves another resource. That causes you issues. One process can bring the whole VM down in a container world. A container can only terminate itself, all this kind of stuff. So you get some of those benefits. Those facets of those benefits lead you into playing really nicely with CI/CD systems, Docker files, or just code. They can be linted. Container images can be checked for CVE type vulnerabilities. Yeah. And the whole world is moving to microservices architectures now. Developers really like building in that way. And this lends itself really nicely to that kind of approach to building your software. Sure. That's a real flash through it, but containers, that's kind of how you start with containers.
But even just, listen to that, Stuart, there's lower cost overhead, there's some security posture benefits, efficiency to be gained for business because of your ability to roll out applications quicker, deploy them and manage them through code. That's an important facet. And I guess once you get to any sort of scale, there's an opportunity to elegantly manage these platforms at scale. Containers, it's easy. I mean, we talked in the previous episode about the operational overheads and burden of managing really large virtual machine estates, and a lot of that was to do with just managing the operating system itself. With the shift towards containers, it takes a lot of that operational system overhead just away. But containers have been around the industry for some 15 plus years. If I go back to my days working in really large organizations, they were relatively prevalent in developer environments. Developers were using containers to deploy their applications onto their laptops, their desktops, into data center kind of hosting environments. But it kind of largely stayed, in my own experience, inside that developer community. We've really seen that change in the last 4 or 5 years. I mean, what's that about? Why is this pretty significant uptick in adoption over the last 5-6 years, as opposed to the kind of 5-10 years before that? What's drove that?
Yeah, I think there's a couple of things there. So as you say, containers, nothing new, right? So BSD jails and all that kind of stuff are years and years old. Docker made it really easy to come along and make the software package with Docker files and package it up really easily. You still had a problem of orchestrating those things and running them in different targets and some of the issues. We'll talk about Kubernetes. We'll get into some of that, but actually running them at scale with all the right properties so that you can trust that they're running properly and observability and all this other stuff. Yeah. Kubernetes is the orchestration layer on top that really gives you all of that. And that's not an old piece of technology now. I don't know what it is, like 6 years or 7 years old or something. Yeah. But was kind of battle hardened inside of Google, because I think it was called Borg or something inside of Google. And when they released it, it was pretty good instantly, right? That's why the adoption's been so good. But yeah, I guess going into what Kubernetes gives you on top of containers is probably where we go next.
Yeah, so I guess Kubernetes you're saying is part of the why. Why now, sorry.
Yeah, I sketched over that a bit. Yeah, the Kubernetes makes it really easy to run containerized systems, essentially. Yeah. But what does it do for you? For the start, let's get an orchestration component to it. So with VMs, you'll have a hypervisor that's managing where your VMs go, maybe where you place them, what happens if you want to move one from one node to another, what happens if one fails. Kubernetes gives you a lot of that kind of orchestration stuff for containers. So where the container is going to run, so you've got a cluster essentially. You always have a cluster. But which node am I going to put my workload on? The one that's got the least resources being used at that time, the one that's got the right profile of CPU versus memory, the one that's got the GPU, all this kind of placement strategy stuff. Kubernetes is going to handle all of that for you. There's a lot of self-healing. Kubernetes has these reconciliation loops where it's constantly checking the state of the system. And if your pod dies, it consumes too much memory, and memory kills itself, for example, Kubernetes will bring it back up again. If the whole node goes, Kubernetes will handle taking the pod from that node and placing it somewhere else for you. If you tell it you always need to have 5 pods running to support your workload, 5 containers, typically, it will handle making sure you've always got 5 and they're always distributed in the system in the right way. So that kind of orchestration and self-healing is a really big part of Kubernetes. There's strong scaling built in, so horizontally scaling your application, so you have more instances of it to support the workloads. Scaling up by adding nodes, that automation of scaling in and out and up and down is all handled by Kubernetes. It's got internal service discovery. It handles DNS for you, handles IP address management. You get automated rollout of the software. You can progressively roll your software out, and if it starts failing, Kubernetes will roll it back for you. I think there's a ton of benefits like that.
And it sounds like Kubernetes is a big part of that. So when I think about, I guess there's an inflection point that's come around in the industry where cloud has become much more pervasive. Cloud services lend themselves to much higher degrees of automation. Kubernetes has come along as a management and orchestration layer to be able to manage containers at real scale. And where these things have come together, I guess big part of the why now is all that stuff has come together over the last 4 or 5 years, which makes the whole business of running containers at scale much more appealing to especially mid to large size businesses. I guess, the big streaming services and the really, really large businesses have been doing this for some time, SaaS providers, but kind of mid to kind of corporate and large organizations that typically we serve really see the benefits and there's huge appeal.
Yeah, I mean, I guess the big companies that you kind of mentioned have demonstrated the technology running at that kind of scale, right? With your Google, your Google Maps, or your I think the back end of Pokemon Go is all containerized and stuff like that, right? But yeah, realizing those benefits and the processes and controls that go around building your software in that manner makes it possible to get your software out better, faster, cheaper, more reliably. And any customer of the competitive market, that can be your competitive edge, right? If software is your business, getting it out, features out to customers quicker, more reliably, less failures. A lot of the stuff you get from doing this stuff in a professional way is one of the drivers of people moving to this stuff now.
So you've got, in terms of summary, I guess, Kubernetes coming along is a big thing.
Mm-hmm.
The whole ecosystem, including cloud and automation, has matured. Application development communities are moving towards microservices in a significant way, and containers really support that movement and that process. But, we talk a lot in our business about enterprise container platforms because that's what our customers want to do. So could you just talk a little bit about that, Stuart? We can talk about containers and Kubernetes, but I know for sure that when we look at enterprise container platforms, there's a whole lot more about that in order to provide an enterprise container platform that can host an array of production services at scale. Do you just want to unpack that a little bit?
Yeah, so I think with this and any other type of system, right, especially in the cloud these days, you can go along, point and click, and you've got what looks like a service. For the enterprise side of things, for whatever you deploy, it's not quite that, right? And I think this is most of the things you would do for an ECP aren't different to what you would do for another enterprise grade system. And I think what those things are full automation, end-to-end automation, so that you can bring up the infrastructure, you can bring up the required services that you need to use that infrastructure. You can bring up the orchestrator itself. You can bring up the pipelines that build and test your containers for security, vulnerabilities, CVE type stuff, for open source license exposure, for code, whatever makes sense for your business to check, all that stuff in place. And the clusters themselves, they be part of the deployment process of pulling the software down when they trust it's in the right place. And there's a whole secure supply chain piece there, which is probably another long podcast in its own right. But that automation soup to nuts, being able to press a button and cleanly build the environment, cleanly destroy it, and however many you need in your business, it should be key thing with the enterprise container stuff. It's typically at scale, right? Yeah. If you're only going to have one, there's no point going to that level of effort, but you don't have to get to too many more than one for it to be worthwhile to invest in the automation side properly. Inside the automation bit, there's a kind of governance piece as well for enterprise grade, where the kind of security checks have kind of touched on with whether it's CIS hardening for Azure, let's say, CIS hardening for Docker, for Kubernetes, CVE type checking, governance around what's good for your business. So we would typically do Terraform compliance type tests, for example, where we would test that the infrastructure has been deployed in a manner that makes sense for your business, and that has to be in a certain location, has to have the certain metadata tags, has to be using all the availability zones, has using some of the HA type properties of the services that you're using. And all that stuff is built into the automation pipelines to check the whole checks and balances of, are you deploying what you expect, and is it meeting your requirements? Cost control is becoming bigger and bigger, and we've got a lot of customers who charge back to either internal teams or to the customer the price of running the service. So that granular cost monitoring, cost control, exactly how you're spending the money, how you're the compute and storage resources and you're paying good money for, how you're using those, and how that spend has been done efficiently and charged back efficiently is becoming more and more important.
We know that enterprise container platforms, what we see in our customers is there's a significant upfront overhead in design and engineering, building an enterprise container platform. But I guess once you've done that, all the applications and services that then get deployed derive all of those benefits that have come from that upfront engineering. And there, Stuart, you talked about, security and observability, and your ability to report, your ability to run these platforms, at scale with all the right controls and policies. And that's what it's all about, really. We know that customers have got the option to go and just readily deploy PaaS services that give them containerization type capabilities. But I guess when I listen to you talk about enterprise container platforms, it's really about all of that other stuff, isn't it? It's been able to derive all the benefits for all business applications through a single platform and single method.
It is, yeah, and you want to make it as easy for developers to deploy their stuff, right? You don't want them to have to understand too much about, the infrastructure. You have to know. You want them to be involved in understanding what they're using, but equally, you don't want them to have to know to the nth degree the stuff about the infrastructure they're using, or how monitoring works, observability. There's things that they shouldn't really have to worry about to get their services published. You want to give them that, and the automation and governance and all that stuff that you put in place, and the core services you give them inside of Kubernetes. If it's, secrets management, if it's, you can make Kubernetes handle external DNS services and put DNS entries in for you, or anything that they need in that regard, you want to pre-build for them. And then any cluster they bring up, all they've got to do is put their software in, and away they go. In an ideal world, it's not always that simple to get there, but that's what people should really be striving for with a platform like this. And observability is a kind of big one as well. That's talking about what makes an ACP. Logging and monitoring, people tend to be not bad at.
Yeah.
Getting the alerts in properly is always difficult. There's no free lunch there. And the response to the alerts when things go wrong, that's where we try and kind of help a lot.
I guess you've covered some of the why containers, Stuart, and why now. Kubernetes is a big part of that. The ecosystem generally has matured. Cloud has become more pervasive. Cloud services lend themselves to higher degrees of automation. So there's a bunch of things that have come together that creates this inflection point. Another part of it is just market trend and market forces. We know that today that all large businesses are having to compete pretty aggressively on some level in the digital space because we're selling more services online. Almost any business, bar some exceptions, have a big drive to sell online. Development teams and digital teams are competing to be first to market with releases of features and components. So some of that is done through, iterative release. So those kind of digital transformation programs are driving certain behaviors, and Kubernetes really lends itself to, and so does containers and Kubernetes together really lend themselves to making that whole process much, much more efficient. So, that's also a big part of it, just market drive and trends and forces.
Most customers we're dealing with that have a digital transformation program, containers is quite high on the agenda. It tends to be one of the key digital transformation drivers, and kind of the larger customers we have that maybe haven't got the most modern technology stack at the minute, so VMs and that kind of thing.
And if you think about the flow, right, so you've got the boardroom level and senior management within large businesses want to go and win in the digital space. They want to compete online aggressively. What that does is it drives the application development teams to be able to have to pick up the pace at which they're releasing software and features. And your ability to do that with container technologies is way, way beyond what they could ever achieve using virtual machine and traditional IaaS. I know that we've focused, especially in the last episode, about the overhead operationally of managing very large IaaS estates and the virtual machine sprawl that we've seen over the last kind of 10, 15 years or so. But more if you get away from the operation and just look at features and capability, your ability to release application updates and features at pace is massively enhanced through using a whole array of cloud native technologies. But containers is a big part of that.
Mm-hmm, mm-hmm.
And you've touched on security policy controls a couple of times during this conversation, and I guess that's a key aspect of what we do when you're dealing with larger organizations. Having all that in place is a big aspect of it. And I know that there's probably a whole episode around GitOps and supply chain security, linked to DevSecOps and what that's all about. And I think we'll cover that in another episode. But that's an intrinsic part of the design process.
It is. It might be worth touching on DevSecOps.
Yeah,
maybe
for sure.
Not go straight to GitOps because, as you say, it can be complicated in its own right, as with supply chain security. But I think the DevSecOps part is important because DevOps and DevSecOps, it's important to be clear about what you mean with those two things. And the DevOps bit is a part of the stuff I've been talking about with getting the systems deployed and destroyed cleanly with all the things you need. The security part, what it means for us really is getting the security to be an intrinsic part of the process. So when you deploy a pipeline that's going to deploy your infrastructure, your software, or whatever it is, The security testing's inside of that pipeline. It's published. Everyone can see it. The person who's pressing the approval button on the pipeline can see the security stance before they do it.
Yeah, and we know from experience, Stuart, when you invite security professionals along late into the project, that's not well received. And it often causes a bit of a pause to your project because a lot of the security requirements that the CISO teams and the information security and cyber teams need has not been addressed. But I guess we are big advocates of addressing that at the early in the design phase and getting the security teams involved.
Yeah, the bigger the customer is, the worse that is.
Yeah.
And the later you leave it, the harder it is to retrofit. You can end up doubling your project costs by having to recut everything by not getting that right. So yeah, not only bringing the processes inside the pipelines and things so that they are intrinsically part of the process, bringing the security team in as well and having them as part of the team that builds it, that can see all these controls, that understands how they can see them, investigate them, and maybe even have them as part of the approval processes for deploying things. And so start to share the responsibility between the dev teams, infrastructure teams, and the security teams for getting security right. Security will always define the standards, but you should be really trying to distribute the responsibility for getting it released properly. It's everyone's responsibility at the end of the day. So yeah, that kind of collaboration aspect, I think that's DevSecOps is not just about the kind of processing part, the pipelines and things. It's also bringing the right people into the right part of the processes at the right time and building it with the right level of clarity to be able to trust the system at the end of the day once it's out and deployed.
So, I asked the question at the start about, about enterprise container platforms and what does that mean versus just containers and Kubernetes. And it sounds like, you've covered things like security and getting that right out of the gate is an important part of that enterprise container platform design and build. Observability and reporting is important. Cost reporting, people as they begin as customers consume cloud, knowing what that costs and why it costs what it costs is an important aspect that senior management teams need in front of them, and having all the right controls and policies that help the environment stay manageable is part of the enterprise container platform. And I know, Stuart, that we do in the work that we do with customers, we also spend a lot of time in R&D in a lab trying to build, a library of kind of reusable components that ultimately bring value to the market. Maybe worth just touching on some of that, some of the things that we do. And I guess it's driven by trying to get to a position where the customer doesn't have to do it, something we can arrive with some just value straight out the gate beyond what the ecosystem of technologies gives you.
Yeah, so we've obviously been doing this a while now. When we build stuff, we don't want to build it new every time. We want to really build reusable components to build our platforms. And that benefits us because we get reuse, and it benefits the customers, as you say, because we can help them build faster if they've not already built that kind of stuff before. The type of things we start with are modular Terraform code bases, Terraform that's built with all the right kind of linting processes, so the code's good, so the documentation is done properly. It's got version control, lifecycle management. You try and treat the infrastructure as code base with the right kind of software development lifecycle respect, as you would with development code. Those composed into Terraform root modules, which really are the things which deploy the infrastructure environments to the customers, kind of, what would you say, their specifications, the requirements. So the lower level building blocks composed into the bigger blocks that deploy the systems. That modular approach we also use inside of the DevOps pipelines. So we typically use Azure DevOps, but whatever the tool is. What we see a lot of is with things like the DevOps pipelines is there's a lot of cut and paste going on. So people build a pipeline that does something, they want to deploy another one that does something similar, that gets cut and pasted, the variables get changed. Yeah. And that can cause real problems at scale, and it has security issues, and it's easy to forget some of the prerequisites like the security checks and stuff. So we try to build the DevOps part in a really modular way as well, and it's a similar approach to the Terraform side, is that the modular building blocks for the pipelines are composed into the higher level pipelines which deploy things for you. Like, for example, if you deploy Terraform, we will always do things like infra cost against it, so we can see a cost estimate of what we're going to deploy before we deploy it. We will always bring out the Terraform plans into these HTML reports that we publish inside the DevOps engine. We'll do secret leakage protection with things like, Git leaks or Trufflehog or something. Every time we do it, we know that's going to happen because the pipelines are built from the lower level building blocks.
As well as some of the automation components in this library of code that we built, and hopefully design patterns that are built to really good standards. I think so far what I've seen is generally well received, but we do a lot. We've kind of gleaned over it today, but as well as the platforms we build on the Microsoft Azure platform, enterprise containers with AKS is part of that. But I know that we're quite careful about selecting the most relevant CNCF technologies to bring into the build and the kind of automation of those platforms, and having to integrate those technologies so that that's a bit easier for the customer, and when we can help accelerate getting to an enterprise container platform that's production ready with all the right tools, processes, policies in place. So I guess tool selection and just having experimented with a variety of tools during our R&D process to arrive at the right example set of what makes a good deployment as part of the process.
Yeah, there's a couple. I guess there's a couple of bits to that. There's as you mentioned, the Cloud Native Computing Foundation. We try to follow their shepherding of what they think the right technologies are going to be. They go through a promotion process from kind of sandbox through to graduated and levels in between. So we try and make sure we're kind of on top of at least the graduated ones and which ones we think might be graduated from the lower levels. Customers' usage as well, obviously. We've worked with a lot of customers doing this stuff. So the ones that we know are really being used, we'll put a bit of effort into as well. And not just CNCF, third-party technologies. So big fans of stuff like Sneak.
Yeah.
Put Sneak in, Caverno, Open Policy Agent, whatever we need to, we'll have a look at and package up. And a lot of our work in the last few years is looking at things like continuous deployment systems for Kubernetes, like Argo, and we really like Flux, is packaging up all this kind of software that does this stuff. I mentioned external DNS, external secrets for secret management, ingress through Nginx, or I don't know, Istio Gateway. Big library of all these kind of components that we've been shepherding or customers are using over the years that become really reusable components, especially inside of Azure, because they're pre-configured to use, Azure identities and things. So I've mentioned external DNS a few times. We've got packages that put the service in that does that, but it then understands how to administer a DNS private zone in Azure, put the DNS records and the A records for you, so it just magically gives you DNS. And all the permissioning that goes behind that is all kind of pre-done inside our package. So we try and get to the point of, you can almost a la carte pick from a menu of the kind of services that you want, and they'll get deployed and be fully configured inside the environment to make it as easy as possible to kind of deploy and consume these services. And
you've used the word building blocks, or the phrase building blocks, a few times, and that's how it sounds to me. There's a building block of code that can be selected for a given deployment scenario. There's a building block of design and engineering patterns. There's building blocks that include the CNCF toolset that are right to do a particular job. So I think that's quite a neat way to think about it. And I know this is a relatively dry subject, and I'm pretty sure that anybody who's not working in the container space will have lost that part of the audience by now. But if this subject does interest you, the team at DevOps Live, March 6th and 7th at the Excel Centre in London. If you happen to be there, swing by the stand. If containers is interesting, we're going to talk in a bit more depth around that whole subject at the event. Please come along and say hi.
And if you'd like to get in touch, please email dirk.anderson, stuart.anderson, or solutions@blakyaks.com. For more information, visit blakyaks.com and find us on LinkedIn, Twitter, and Instagram @BlakYaks.